Hello again, my name is Michael Benben, and today I'll be going over video assignment 1 for Calculus 2000 in Challenge 2016, where we were given 4 different parts to go over, constituting anything from chain rule to the inverse derivative function. To begin, we're going to go over the chain rule, which states that if two functions f of x and g of x that create the composite function f of x are differentiable, then f of g of x is differentiable at x, and f of g prime of x is equal to f prime of g of x times g prime of x. In order to better show how the chain rule works, here I made up an example. We're going to solve f of x is equal to sine of x squared using the chain rule. The best way to do this is to break down the function into the two different functions that are within it. So we have f of x is equal to sine x, and we have g of x is equal to x squared, and then the derivatives of each, f prime of x being cosine x, and g prime of x being 2x. With that now, we can look at the equation for chain rule, and know that we're going to find the derivative of f and plug in g of x, so we have cosine of x squared, and then we're going to multiply that by g prime of x, which is 2x. In the end, the derivative for this function would be 2x cosine x squared. Now with the chain rule, we're able to derive the definition of the derivative of an inverse function. So here, we're going to let the inverse of f of x equal g of x so that we can see these terms much easier. So g prime of x is going to be equal to 1 over f prime of g of x. Next, we're going to look over here in the blue. These are many different equations that we're going to need to know in order to go through the problem. First, we're going to start with f of x, which is tangent, its derivative, secant squared of x, its inverse, arctangent of x. And then we're going to start here in red and go back to the other equations afterwards. So g prime of x is equal to 1 over secant squared of arctangent of x due to this equation. Next, we're going to follow over to g prime of x here in green. We have 1 over tangent squared of arctangent of x plus 1. Now we got that from this other equation here, where we know that secant squared of x is equal to the tangent squared of x plus 1. Now that we know what secant squared of x is in relation to tangent, and we plug in arctangent into there, this last part right here shows us that f of its inverse is equal to x. So since tangent is squared and its inverse is plugged in for x, then we're going to get this final equation and the answer to our problem, which is 1 over x squared plus 1, which is the derivative of arctangent. Another way we can use chain rule is to solve a problem that not only has a composite function with 2 functions in it, but one that has 3 functions in it. So here we're going to look at f of g of h of x and find its derivative. But before we do that, just like the chain rule states, we need to state that f of x, g of x, and h of x must be continuous on the closed interval from a to b and differentiable on the open interval from a to b. That we can use the chain rule and apply it one extra step. So here we have the derivative of f of g of h of x is equal to f prime of g of h of x times g prime of h of x times h prime of x. And then we will now be using this and applying it to a problem that has 3 functions in one. Now with the previous 3 parts that we just went through, for this last part, we'll be able to find the derivative of this function, which is arctangent of e to the power of tangent x. And we're going to solve it at x equals 0. Here in blue we have the equation that we just derived for the derivative of f of g of h of x. And now we're going to break down this problem in order to fully understand it. First, we can recognize here in red that there are 3 functions in the problem. So we're going to use f of x as arctangent, g of x as e to the power of x, and h of x as tangent x. So now we're going to need the derivative of each to be able to continue solving this problem. Earlier in this video, we derived arctangent of x and got that its derivative is 1 over x squared plus 1. We know that the derivative of e to the power of x is e to the power of x, and we also used the derivative of tangent x earlier, which is secant squared of x. So now we'll be using all of this to be able to apply it to this equation and find the answer to this problem. Now we're going to derive the function. First, here in blue, we end up with 1 over e to the power of 2 tangent x plus 1. Here we have e to the power of tangent x. And lastly, we end up with secant squared of x. So our final answer is e to the power of tangent x times secant squared x over e to the power of 2 tangent x plus 1. Now rewritten here we have the equation f prime of x that we just found, and now we're going to plug in 0. So f prime of 0 is going to be equal to e to the power of 10 of 0 times secant squared of 0 over e times 2 tangent of 0 plus 1. Now we know that tangent of 0 is also 0, and secant squared of 0 is the same as saying 1 over cosine squared of 0, which is 1 over 1, and when we square that, it's still 1. So, in the end, we end up with e to the power of 0 times 1 over e to the power of 0 plus 1. Now that we've plugged in 0 for all the values of x, we have 1 times 1 over 1 plus 1, and therefore we get f prime of 0 is equal to 1/2 for arctangent of e to the power of tangent x at x equals 0. And with that, that is the conclusion of the chain rule and inverse function rules for the derivatives. And I'll see you in the next interactive video.